Hi guys. So in continuation of our earlier lecture on Bayesian classification, so we'll be continuing from what way we have ended last lecture. So in today's lecture, we will see the Naïve Bayes classification method. We'll see that with the help of an examples, and Bayes classification, it has some problems as well as the solution also exists for that. So we'll be discussing those problems as well as the solutions. So first is Bayes classify what is it, that it is based on the Bayes theorem. We have seen how is it, right? So now just a formally if I can write, suppose y is a class variable and x is equals to this, x is the set of, so if y is a class variable means y1, y2, y3, whatever. Now if there are 4 classes, so y1, y2, y3, y4 the classes. So I am using variable y for the classes and variable x for the set of attributes, where x consists of different attributes x1 to xn. Say it has n attributes, and x is a set of attribute with an instance of y. For each attribute it has an instance of y, maybe x, maybe x1, x2, xn takes, if it takes this value, and this class is say yi. Okay. So classification problem then can be expressed as a class conditional problem. How we can express using the Bayes theorem we have seen, right? So what is the probability that my class is equals to yi, my class is equals to yi, given that my attributes are x1 is equals to x1, this capital X2 is equals to small x2, capital Xn is equals to small xn. These are my attributes. This capital X1, X2 are these are the attributes, and these are the attribute values x1, x2, these are the attribute values. So what we have to find out is a class conditional probability. It is a conditional probability, right? So we call it a class conditional probability. What is the probability that y is equals to yi, that my class is equals to yi, given my attribute values are x1, x2, x3 up to xn. If this is my attribute values, what is the probability that my class is yi? Okay. So we have already seen that we use Bayes theorem for that, remember. So now using Bayes theorem on conditional probability, we have seen this is the expression for this Bayes theorem. Probability of y given x, how do we write? So that is probability of x given y into probability of y divided by probability of x. This probability of x is nothing but the total probability. Remember, if I draw it this way, suppose this is my sample space, this is my whole universal of space. So these are the 3 distinct classes. This is say y1, this is y2, this is y3, and this, suppose this circle is suppose x. Okay. So if what I want to find out, given certain attributes for this x, what is the probability that my class is y1, what is my probability that my class is y2, what is my probability that class is y3 for given set of attributes x. Okay, so we have to find that basically. So this is nothing, this is, we can directly just get it from the Bayes theorem. Bayes theorem also gives us that only. Probability of y given x is probability of x given y into probability of y divided by probability of x, where probability of x is nothing but this total probability. So how do we find out probability of x? This is how we find out probability of x, the total probability. How do we find out? Probability of x is probability of y1 intersection x union y2 intersection x union y3 intersection x, right? Because x is formed by these 3 disjoint sets. y1, y2, y3 is a disjoint set, x is formed by these 3 disjoint sets. So x is nothing but it formed by these 3 disjoint sets, so it is nothing but just addition of all this. So addition of intersection of y1 intersection x, y2 intersection x, and y3 intersection x. So basically if we extend it, so we will get something of this sort. Okay, this is the denominator. Okay, now you just tell me one thing. So if this is probability of y given x, means this will be, we can find out for any of the class what is the probability of y1 given a set of attributes, what is the probability of y2 given a set of attributes, what is the probability of y3 given a set of attribute x. So whatever it is, this numerator will change, but then for all the cases my denominator will remain same. For all these cases, even if I write it y1 or y2 or y3, my denominator will remain same. Only what will change is this portion, this numerator will change, isn't it? So that means I can write probability of y given x as I can just use this proportionate term. Probability of y given x is just proportionate to this portion. I can write is almost equal to this probability of x given y into probability of y. So basically I have to calculate this probability of x given y into probability of y if I need to find out probability of y given x, because probability of x will remain same for whichever classes I try to find out. Okay. So now, so that's it. So probability of y given x can be taken as a measure of y given x, that is, this is denominator time, since it will remain constant for whichever term I need to find out. Did you get it what I want to say? Suppose I want to find out probability of y1 given some variables x, then what will I get? I will get probability of x given y1 into probability of y1 divided by probability of x. Similarly, if I try to find out probability of y2 given x, some set of attributes, x I am not differentiating, it is a tuple, one tuple basically, and tuple consists of a set of attributes. So it will be again probability of x given y2 into probability of y2 divided by probability of x. Similarly, probability of y3 given x is equals to probability of x given y3 into probability of y3 divided by probability of x. So see, probability of x, probability of y, probability of x remains same, denominator remains same. So what changes is only the numerator. It changes based on the, we are trying to find out the class conditional probability of which class. It changes basis on that. So that's why since this remains same, denominator remains same. So just we can write this as just almost equal to this term, or we can, instead of this I can use this term, that is proportionate to this term. Fine. And now what is this probability of x given y and what is probability of y? Last lecture and I think almost the last lecture, last slide we have seen this. Probability of x given y we call it a posterior probability, and what is probability of y we call it as a prior probability. So given a set of data, so you will have to find out a posterior probability, we have to find out a prior probability. If we can find these two probability, then finding out probability of y given x will not be a difficult task. Now suppose for a given instance of x, say x1 is equals to x1, for a given instant of x, suppose it takes value x1, x2, small x1, x1, x2, x3 up to xn. For a given instance of x1, suppose consider that there are just two classes, that is y1 and y2. There are just two classes y1 and y2, and this set of observation we have to classify it into these two classes, either y1 or y2. Now consider that it has just two classes y1 and y2, and for a given instance of x, suppose this is the given instant of x. So what we will find out in Bayesian classifier, what we do is that we try to find out this given instance, we try what is the probability that it falls in the class 1, what is the probability it falls in class 2. If it is two classes, if it is three classes, we will try to find out what is the probability it falls in all the three classes. Then we will consider that class which has the highest probability. Okay. So we will find out for probability of y is equals to yi given x is equal to x, and probability of y is equals to yj given x is equal to x. We will find out the class conditional probability for both the classes. Now whichever class conditional probability is bigger, higher, that class will be considered as the class for that set instance of x. So if y is equals to yi is greater than probability of y is equals to yj, then we said yi is more stronger than yj for the instance x is equal to x. The strongest yi is the classification for the instant x is equals to x. Fine. So that's how we use Bayesian classifier. So if it is still not clear, if you have still some doubt, we will see an example, then with this example it will be more clear. Now let us will illustrate it with an example, the same example which we have seen in the in our last lecture. We have seen this example, right? But that time we did not solve it. We have just kept the example. Now we will be solving. Before that, before solving this example, let me come to that. We have seen a simple example. So just let me write that. Quickly, I'll write there total 10 data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data. And remember, we had x value and y value. So x value is x1, x2, x3, x3, x2. I have the data in front of me. I am just copying it. x1, x1, x3, x2, x2. This is what we have. And for this y, we have there y, basically it is a class we have, that is two classes, A and B classes we have. Okay. So, this was the data for last class, if you can remember properly. So, this was the this y variable indicates the class, and this is this attribute. It is just a single attribute. Each tuple has single attribute. Okay, the attribute is x, and these are the different values that are x takes. So, we want to find out the prior probability and posterior probability. Suppose now let's find out the prior probability. What is the prior probability that y is equals to a? So, y is equals to a, how did we find out? So, how many instances of a is here? Total you see there will be 2, 3, 4, 5 and total 10. So, prior probability is 5 by 10. Okay. So, then we also found out the posterior probability, that what is the probability that x is equals to x2 given y is equals to a. So, this given y is equals to a, there are two such cases. Okay, this one and this one. So, how many a cases are there? Total 5. So, it is 2 by 5. Total there are 5 a. For y is equals to how many x2? 2 x2. So, 2 by 5. This was my posterior probability, this is my prior probability. This is how we calculate. Now, see for what is the Bayes classifier? The thing is that what was the expression? So, what is the probability of y given x? Probability of y given x, how do we write? We write it as probability of x given a into probability of a. So, see, this is the posterior probability, this is the prior probability, this is how we calculate it. We got this too, so we will be able to find this out. Fine. So, now we will see for the example. See here. So, it is air traffic data, which I have explained in my last lecture also. So, these are the things, different attributes. It has total 4 attributes. What are the attributes? The attributes are day, season, fog and rain. These 4 are the attributes, and the classes are this is basically, as I mentioned in my last class, this is means it has noted the flight that comes to New Delhi from different airports. Okay, from different airports, the flight that has reached New Delhi airport, that we have taken. So, the different classes are, we have total how many classes? One is on time, one is late, very late and cancel. So, total we have 4 classes. Whether a flight is on time, whether a flight is late, very late or cancel. Okay, and this we have based on the 4 different attributes. Remember, by Bayesian, I have already mentioned that all the attributes are independent, first thing, and all the attributes had equal contribution. Okay, so here days, whether it is a weekday or Monday or Sunday or a holiday, it has no dependency on what is the season, it has no dependency on the fog, it has no dependency on the rain, but that is very much unlikely. As season, rain and fog is very much dependent on the season, right? But actually in Bayes classifier, we don't consider those dependency. We will just take that as all the attributes are independent as well as all has equal contribution, but that it is not deterministic. We cannot say if it is a weekday, if it is a spring season and there is no fog and then rain, definitely it will be on time. We cannot deterministically, we cannot say there is an concept of uncertainty to it. So, that is why we do it's a probabilistic calculation here. So, these are the things we have these are the attribute, these are the classes. Now from this data, what we have, what to say, this days data, season data, fog data, rain data, from this data we will calculate the posterior probability and the prior probability. How do we calculate the posterior probability and prior probability? See, so remember we have found out in just the example what I have shown you prior probability, what we have found out? We have found out the prior probability of all the classes. Just now the example which I have shown, we have found prior probability of y is equals to a. So we can also find out prior probability of y is equals to b. So this I am calling it as a prior probability. So what is a and what is b? These are nothing but the classes. So here which are my classes? On time, late, very late and cancel. So I will have to find out the prior probability of this on time, late, very late and cancel. So now how do I find what to say, how do I find out the prior probability of this on time? It is in the next slide. It is, see, prior probability is 14 by 20. Prior probability of on time is 14 by 20. Why it is 14 by 20? See here. So how many datas are here? Total, you see, if I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, total 20 datas are here. So total 20 datas are there. Out of 20, how many are on time? Just now we have calculated out of A and B, how many are A, right? So how many are on time? So if you count on time, you will see 14 are on time. 14 are on time. Out of 20, 14 are on time. So prior probability of on time is 14 by 20. Okay. Similarly, out of 20, 2 are late. That we can very easily see here. See, there is one late here and one late here, no more late. Okay. So prior probability of late is 2 by 20. This is the prior probability. So similarly, prior probability of very late there are 3 occurrences. So this is the prior probability. Cancel, there are 1 occurrences. Okay. So this is how we find out the prior probability. Now the thing is that we will have to find out the posterior probability. What is the posterior probability? So what is the what we need to find out? We need to find out probability of y given x is equals to probability of x given y into probability of y. That's what we need to find out, right? So this is my posterior probability. What is probability of x given y? Given that it is on time, what is the probability that it is a weekday? Now see, earlier the datas were this way scattered. Now we have made it in a way I bought all the days together, season in one, then here fog, then the rain, the different attributes, the different values that the days take, I put it together, different values the season take, I put it together, the different values that the fog attribute takes and the different values the rain attributes take. So the different values that the day attribute take is weekday, Saturday, Sunday and holiday. So what is the probability? Given that the flight has arrived on time, what is the probability that is a weekday? Okay. So on time it is 14. Out of the 20 occurrences, on time it is 14. We have already seen here. Total on time 14 is there. Out of on time 14, how many are weekdays? So this is one on time and weekday. This is another one on time and weekday. Another one on time and weekday. This way, if you see, you will see total there are 9 weekdays which have reached on time. So my posterior probability is 9 by 14. Fine. Similarly, for Sunday, what is the probability that given that it is flight is on time, what is the probability that it is a Saturday? There are 2 such instances. So it is 2 by 14. Similarly, I found out the posterior probability of all this Saturday, Sunday, holiday. For spring also, given that it has reached on time, what is the probability that the season is spring? Okay. This like season is spring, this is on time here. Again, where we have season spring, this is cancel. This is season is spring, this is on time, season spring, on time, season spring, on time. Okay. So spring also there were 14 occurrences. So spring it is 4 by 14. Fine. I mean sorry, season also there is 14 occurrences. So this way we can find out the we can find out the posterior probability. What is the what is the probability that it is decision is spring given that it has the flight has reached on time. So, on time there are total 14 occurrences, fine. So, now how many occurrences of spring, how many occurrences of summer, how many occurrences of autumn, winter. Now, similarly here for late also, given that it has reached late, what is the probability that it is a weekday? For late there are 2 occurrences. So, denominator will be 2. Similarly, for very late, we find out all the posterior probability. Once we found out all the posterior probability, so we found out all the posterior probability, we found out all the prior probability. Now, the task is just we have to find out what is the probability that given an attribute set, what is the probability that it is on time or late or very late or cancel. So, suppose this instant is given, my day is a weekday and a season is winter, fog is high fog and heavy rainfall. I have to find out whether the flight has reached on time, late, very late or cancel. As I already mentioned, I will try to find out the probability of all the classes, and the class which has the highest probability is the class of that instance. So, when we try to find out the probability on time, so what is the thing? Probability that y is equals to on time given that x is equals to this value, weekday, then winter, then high fog and heavy rainfall. This is the case. So, what is this? This will have to use the posterior probability and the prior probability. If you by multiplying all this, I got this. For late, I got this. For very late, this, and for cancel, this. And out of this, which is bigger? Very late is the bigger value. So, case 3 is strongest, hence classification result is very late. So, for this instance, we can say that the flight has reached very late. This is how we do Bayesian classification. So, formally if I state it, given set of k mutually exclusive and exhaustive classes, okay, which have prior probabilities, these are the prior probabilities which we have found out how to find out the prior probabilities. There are n attribute set, these are the n attribute set which for a given instance value a1 is equals to a1, these are the values of different attributes. For each ci belongs to C, okay, I is equals to 1 to k, as we told there are total k classes. Calculate the class conditional probability. We will have to find out the class conditional probability, okay. And then once we found out the class conditional probability, we will take the maximum of the classes and the maximum of the probability, and the class that has the maximum probability that is Cx, Cx is the classification result. This is the same thing if I put it formally, okay. So, now here this pi is not equals to 1, this pi, when I if you sum it, this you will not get this plus this plus this plus this is not equals to 1. This do not expect that you will get this is equals to 1, because that is not a, because they are not actually probabilities, rather proportion values to the posterior probability, okay. So, do not expect that these are the different class probability of getting reaching in different classes is this. So, this must be equal to 1, but here we are not getting what, something is wrong. No, it is not wrong, you will not get 1, because then they are not probabilities, they are but proportional values, proportional to the posterior probabilities. Now, some limitation of Bayesian classifications, okay. So, Naïve Bayes approach is very similar one, that is the advantage which often works very well, but it has some cons as well. So, what is the cons? It relies on all attributes being categorical. Here it assumes that all the attributes are categorical attribute, okay. You know what is categorical, I will not repeat. So, if the data is less, then it estimates poorly. For this, for Bayesian classification to work fine, work really very good, we need a huge amount of data. Lesser the data, poorer the estimation. Then sometimes what happens, we have instead of categorical values, sometimes we get, because the Bayesian approach assumes it's a categorical value, sometimes instead of category we get some continuous values. So, at estimating the posterior probability for continuous attributes, sometimes if our attribute values is not categorical but continuous value, then what we do in real life situation, all attributes are not necessarily be categorical. In fact, there is a mix of both categorical and continuous variables. sometimes it is categorical. Of course, all in real life it is not, we cannot expect that all the values will get it categorical only, but Bayes its take is categorical. So what we will do, sometimes we get it continuous values. Again, sometimes what we get for one for one particular class we will get different values. So for one particular class we will get too many values. Then also we find that is, those are numerical attributes. Okay. Then from that also we can find out its probability distributions. So once we know the probability distribution, we can find out the mean and the variance. So there are two approaches to deal with continuous attributes in Bayesian. First is we can discretize its continuous attribute and then replace the continuous values with its continuous corresponding discrete interval. That is the first approach. That is, the attributes value is continuous. Sometimes what is, instead of continuous we can discretize it and we can take some discrete interval. If we take it an interval, and we can take the midpoint of the interval. Okay. The another is that we can assume a certain probability distribution for the continuous variable and estimate the parameters of the distribution. Okay. Another is, one is we will discretize it, we will consider it that as if it is not continuous, it is discrete, we will discretize it. That way we will be losing some information, of course, and then we will try to find out some interval, discrete intervals. So another is we will not discretize it, we will take it as a form of probability distribution only. So for continuous probability distribution we will try and find out what is the it maps to which probability distribution, and then we will try to find out the parameter using the whatever data are given. Some data observations are given, isn't it? From the observation we will have to try to find out the class. So these observations are nothing but the training data. From this data we will try to, once the data are given and if we assume the probability distributions, so then from the data we can find out the parameters of the distribution. So if it is a normal distribution, what are the parameters? Parameters is nothing but the mean and the sigma. Okay. So once we know the mean and the sigma, then what is the probability of occurrence of x posterior probability? How do we find out? What is the probability that attribute has a particular x value given y value is something, isn't it? So basically we have to find out the probability of x, isn't it, given something. So to find out the probability of x, once we know the mu and sigma, if it is a normal distribution, we can just use the expression. From the expression we know mu and sigma from the we have found out mu and sigma from the training data. The parameters are just mu and sigma if it is a normal distribution. Different distribution has different parameters. From the training data we will find out the parameters. Once we find out the parameters, we will be able to find out the px. Px is nothing but the posterior probability. The Gaussian distribution is usually chosen to represent the posterior probability for continuous. This is the general form, right? You can just take a simple example in the net, you will be finding many examples. You can take a simple example and you can see how it works. So it is beyond the scope of this class to explain a continuous example and taking the mean and the finding out the parameters and putting it here. It's easy, nothing else. Just given the training data, from the training data, okay, you have assumed that this data will be in normal distribution. Okay, there are actually different processes. Now let's not go to those steps. Why you should not assume also. You will try different. There are different curve fitting approach, different probability plotting approach. We will try to find out this data belongs to which distribution. Suppose we know that data belongs to the normal distribution. Once we know that the data belongs to normal distribution, then we need to find out the mu and the sigma. So from the training data, we will be able to find out the mu and the sigma. Once we can find out the mu and sigma, then it is nothing but to find out probability of x is basically solving this integral. Okay, and you don't need to solve this integral. There are again normal tables also. Now, not the Z table which I am talking about. That was cumulative table, cumulative distribution problem. For probability density function table is also available, where it calculates this value. Remember the Z table which we have seen, that was, it is from minus infinity to a particular value. That was cumulative, isn't it? Cumulative distribution function. But for simple density function also probability tables are there. Okay, that's all what I have already discussed. So here the parameter can be calculated based on the sample mean of attributes value of Aj, and for the training records that belongs to the class Ci. Similarly, sigma I can be also estimated from the calculation of variance of such training records. Now, That is one limitation which we have seen that we could easily solve. That is not a limitation at all. If you get a continuous data, we will have to, one approach is that we will have to discretize it and consider discrete interval. Another approach is just fine, let it be continuous, we will assume a probability distribution and we will find out the parameters, then we will be able to find out the probability. That is, second approach is that in our last example, you see in the case 4, when we try to see the cancel classes, there were some 0 data were there. When we try to find out the posterior probability, there were some zeros are there, posterior probability. When we get a 0, when there is no occurrence for that, then we get a 0. So, if 1 0 makes everything 0. So, this is a because then no point finding out the posterior probability. This class will we will not get a representation of this class anywhere. So, then what is the solution for this is called M estimation approach. Okay, Bayesian classification with missing data. When such data is missing, actually, if we would have taken a huge number of data, then maybe that we wouldn't have got 0. But huge data means there is a limitation how huge we can take. So sometimes if we don't take a very huge data, some data are missing. So then how to address that? The M estimation is to deal with the potential problem of Bayesian classifier when training data size is too poor, or sometimes not at all, there is no data at all for some classes. If the posterior probability for one of the attribute is 0, why we got 0 here? Because the posterior probability of one of the attributes was 0. If the posterior probability of one of the attributes is 0, then the overall class conditional probability for the class vanishes. If posterior probability for one of the attributes is 0, the overall class conditional probability also vanishes. You see here, this posterior probability, there were total 4, this is the prior probability and this 4 were the posterior probability. One is for weekday, the day which is, it is a weekday or Sunday or holiday, whatever is, one is for day, another is for season, another is for fog, another is for rain. For day and season, we got 0, but we have representation for fog and rain. But just because we got this to 0, the whole thing, our class conditional probability became 0. So, in other words, if training data do not cover many of the attributes below, then we may not be able to classify some of the test records. Some of the test records, in such case, will not be able to classify it only. This problem can be addressed by using the M estimate approach. So, now what is M estimate approach? In M estimate approach, in the not M estimate, in the normal case, what we do is that normal case when we try to find out the posterior probability. So, this is my posterior probability. Okay, this pen is not working. In the normal case, when I try to find the posterior probability, this okay, this P A of j is equals to x particular parameters, that is if j is equal to s, given my class Ci, what I do is that to find out the posterior probability, I just use this equation n Ci by n. What is n here? N is the total number of instances from class Ci. We have seen that, we have calculated that, isn't it? Probability that a particular value of x given that class is A, isn't it? So, n is the total number of instances from the class Ci, and what is n Ci? Number of training example from class Ci that takes the value A0 is equal to x. So, in my previous example that is what was that weekday. What given that my attribute value is a weekday, what is the probability? Given that it falls in the flight has arrived late, what is the probability that my day is a weekday? Fine. So, that is my posterior probability. So, number of training example from class Ci that takes the value Aj is equals to x. So, in the normal case, in usual case, I should not say normal, in usual case I use this expression n Ci by n. But there are many, sometimes you see, sometimes what happens if we don't take enough data, when my data is poor maybe, there in some case there can two things happen. One is that maybe there is no representation from a class at all, that is a very bad data. If there is no representation from a class at all, then definitely I cannot classify it to that class, that is a very bad case. And next case is that there are representation of each class, but somehow when I try to find out the posterior probability, for some cases I get 0. When I get 0, suppose suppose here when the day is a weekday and train has arrived on time, there is no such cases. For a weekday train has arrived on time, suppose there is no such occurrences in my data. So it is not that that can never happen, that can happen, but the sample what I have considered in my sample, there is no such case. The day is a weekday and the time and the flight has come on time. Given that the flight has come on time and so probably that it is a weekday. So there is no representation in my data. So when there is no representation in my data, then what happened? My NCI value is 0. When my NCI value is 0, then probability of this I got 0. So we have seen it before, isn't it? Here, this 0 value, this 0 value. Why did I got 0 value? Because there were no such instances in my sample. So because of that, I got my whole probability got 0. Though there were representation for some other attributes, but because of this, my whole probability got 0. This can happen when our sample size is not very huge. Even sometimes if we take a very big sample size also, still that happens because some cases may be rare occurrences. So in such cases, to avoid this 0, because 1 0 means will bring the whole class probability to 0, class conditional probability to 0. So that we use the M estimate. So this is the formula for M estimate. So instead of just using NCI by N, what usually we use another 2 more terms, that is MP in the numerator and in denominator M. Now what is M, then what is P? M is the parameter known as equivalent sample size. It is a parameter known as equivalent sample size. Equivalent sample size, M is a parameter, this is a very much a user defined parameter. User can take any value as such, but usually, and one of the heuristic of taking M is that suppose my class is total, my sample size is 20, total sample size is 20, and suppose I have total 4 classes. In this sample, suppose I have 4 classes. So if my sample is a stable sample, it's very much a stable sample, then what I can expect in this sample, since there are 4 classes, 20 samples, that means each class has 5 representation. And if it is a very much stable data, then I can expect 5 representation from each class. So that may not be the case in real life, that may not actually be the case. That way we consider as this equivalent sample size. Okay, so here suppose so if my sample size is 30 and I have total 4 categories, 4 categories of class, so then 30 divided by 4 and I take the integer value of it. That is one of the heuristic of taking the equivalent sample size. Okay, so now next is the P. P is very much a user specified parameter. Okay, so P we can very well consider P based on the application. If it is a very, very critical application, we want very, very precise answer, so we can take a very less value of P. Okay, so again there are different heuristic also for taking P value. So I will be doing some example in my tutorial class, then you will see how we can take P values. I will show just one example, and there are different heuristic for take different P values. Usually P value is considered 0.05 in most of the cases. Okay, so that's how this is the M estimate. So if NCI is equals to 0, here if NCI is equals to 0, but I will not be getting a 0 value because of these 2 parameters. So I will be solving some problem in the tutorial, then things will be more clear. So with that I come to the end of this lecture. So in this lecture what we have learned, we have completed the Bayesian classification method. So we have totally learned the Bayesian classification method, computation of class conditional and posterior probabilities that we have seen, and we have also seen computation of categorical features. Then how we can extend this methodology if we, instead of categorical variables, if we use continuous variable, how we can extend this feature. We have seen there are 2 different types. One is just discretizing it, another is using the probability distribution for that, and then finding out the mean and the variance from the training data, and then finding out the posterior probability for X. When we know the probability distribution, we know the probability density function, right? In a probability density function, put the values of mu and sigma and we will get a value of the probability of X. Then we have also seen when there is some for posterior probability, if there is some 0 value, then how we can solve it by M estimation approach. That also we have seen in this lecture. And so this is the references, and thank you guys.